This use case is presented by Robot Oy from Oulu, northern Finland. The consortium consists of two Finnish companies, Robot Oy and Accuser Oy. Robot Oy is a high-tech company founded in 2006. The main business of the company is to produce automation and robotics solutions for its customers. Accuser Oy is a recycling specialized company founded in 2005. The main business of the company is to provide sustainable battery recycling for used portable batteries. Every year, over 1 million tons of batteries enter the EU. The recycling of this waste is crucial for making sure that the precious materials can be efficiently reused instead of allowing it to end up in nature. The second partner of this project, Accuser, is leading recycler of especially the consumer battery waste in Finland. A growing total of 1,500 tons of waste ends up at their facility every year. The number is growing yearly, and Accuser, as well as similar companies all over Europe, wants to be ready for the future challenges. The process happens in two steps, where all the recycled battery fraction enters the line in the beginning. The first step of the process separates the alkaline, zinc carbon and button cells from the main fraction containing the more precious materials. In this project, the second step was the real point of interest. The material in the second step of the process contains a large variety of different shaped and sized batteries, from cylinder-shaped to e-tool batteries, etc. Due to large variety of the material, several methods for identification was detected already in the early stage of the project. For efficient approach, the project was divided into 4 steps, and the steps are summarized in the following slides. The project started with requirement specification for the system. The 3 main requirements for the system was identified as: the system should handle the fraction gently, any shock, rattle or similar collision can cause a fire in the material. The material is not possibly identified during the first round, so there should be the possibility to circulate the material more than 1 round. And the reliability of the sorting, that different target materials won't mix and the concentration is maximized. Several numeral requirements were of course identified too and set, and based on the requirements, this design and data collection work was started. The data collection phase started with the batch of typical waste gathered directly from the Accuser's production line. The batch was manually divided into larger groups by the shape and the content of the battery. Total of 9 different interesting groups were identified, and based on these groups, the data collection was performed by photographing the material and analyzing what features can be seen with the plain machine vision and what are those issues that needs to be tackled with other methods during the demonstration phase. The design and demonstration phase was the largest part of the project. The work not only included the mechanical planning and prototyping of the system components, but also production testing. The whole work was based on lessons learned in the data collection phase, but by of course taking into account the requirements set for the system in the beginning of the project. As a result of the mechanical designing work, a general model of the whole system was generated for better overview on how the project KPIs can be achieved. During this process, several methods were identified and they were combined as a catalog of solutions. After forming a catalog of solutions and tools for solving the sorting process, it was possible to start observing the challenge from the business point of view. The end-user price for hands-on application depends on various minor selections and for being able to form some kind of a price tag. A conceptual examples of sorting lines were formed. In the related picture, you can see different types of modules joined together for forming various ways to solve the sorting. The final selection should be done from the point of view of how much the line can cost, how much space can be allocated for the system, what part of the fraction needs to be sorted, etc. The main objective of this project was to integrate a system capable of conveying, identifying, labeling, and sorting out used portable batteries. In addition, the two following sub-objectives were set as well. To have a cognitive system which is equivalent to future variation in the fraction, as well as validate the usability of artificial intelligence-based machine vision systems with real-world industrial processes. The objectives were selected to be as clear and straightforward as possible, and despite the pandemic-related problems, mainly all the objectives can be seen as achieved during this project. The main result of the project was a successful entity of knowledge and solutions to tackle the problems in hand, efficiently and safely. After this project, we are able to promise that the sorting can be done automatically and yet cost efficiently. As the modern robotics and automation technologies in general can be applied to all areas of industries, also the results of this project can be exploited to fulfill any type of industrial needs for any branch of industry. Modular automation is easy to modify for suiting better different needs and what is the most important for the customer. Defining the budget for various solutions are easier when the concepting can be done with modules. This project was done in cooperation with the Trinity project. We would like to thank especially Centria for the mentoring of this project. For more information about the project and the companies, don't hesitate to contact us directly.